Hi, this is your Swapnil Bhartiya. Welcome to TFR Let's Talk. And today we have with us once again Scott Sellers, co-founder and CEO of Azul. Scott, it's great to have you on the show.
Thank you, Swap. Pleasure to be with you again. Thanks for the opportunity.
It's my pleasure. And today we are going to talk about high performance Java platform. We hear a lot about, high performance Java platform, but I want to learn from you, what exactly does it mean?
Well, a high-performance Java platform, as the name suggests, is a way to run Java-based applications in a way that drives higher performance. And let me start by explaining generally how a Java application is run. The way that Java works is that when a Java application or a Java-based application is run, there's a piece of software installed on a desktop or a server or virtual container or wherever that application is being run. A piece of software called the JVM, the Java Virtual Machine, is also installed on that machine where the Java application is running. And it's the responsibility of the Java Virtual Machine, the JVM, to run the Java application. And one of the great things about Java in general is the portability of applications. Sun, when they created the Java language, coined the expression "write once, run anywhere," and it really is true. And then the magic of Java is its portability. And the reason it's portable is because of the Java Virtual Machine, and the application, when it's run, actually gets compiled into the underlying instruction set of wherever it's being run. It could be a x86 processor, an ARM processor, ARM64, for example, is now very popular in the cloud. So that's kind of the basic way that a description of how Java applications is run. So back to your question, what does a high-performance Java platform mean? It means that there's a set of products, for example, Azul's Platform Prime product, that in essence makes the running of Java applications run in ways that are higher performance and ultimately create a better experience for the users of those Java applications, reduce costs associated when deploying applications. For example, when you have a high performance Java platform, you don't need as many instances in the cloud, so you're able to have a more optimized cost basis when you're running applications in the cloud. And also, when you really look at an application lifecycle and where time is being spent when an application is being developed and deployed, there's an awful lot of time spent in this loop between the developers and the operators that's evolved around tweaking and tuning the application, getting it high performance, getting it to be able to achieve the service level that the application needs to achieve to meet the needs of the business, whether that's response time or scale or throughput, whatever the application needs to do. And there's an awful lot of time spent in this interaction between the application and the operational side. So a high performance Java platform allows that to be significantly reduced by removing the amount of time that's necessary to tweak and tune and optimize, and instead the application inherently is higher performance and much more readily able to meet the business needs of the application.
And if I'm not wrong, you folks have, Azul Platform Prime, which is a high performance Java platform. Can you talk about what are some of the critical capabilities that are at the heart of a high performance Java platform?
Right, exactly. So Azul's Platform Prime is an example of a high performance Java platform. And there's a bunch of different things that kind of go into what we define as a high performance Java platform. And the three most basic things are, first of all, improvement in terms of execution, code speed, right? Being able to run the application faster. The second is being able to run the application more consistently. And the third is being able to address problems associated with Java applications in terms of how long it takes an application to start up and get fully optimized, which is called the warm-up problem. So a bit more detail on each of those. So code speed is fairly obvious, right? As an application is run, the JVM is responsible for dynamically compiling that application into the underlying machine where it's being run. And so the better the compiler, the faster the code runs. And so a high-performance Java platform allows the creation of more efficient code, higher performance code, and ultimately allows for higher throughput, lower latency, in essence, just faster code, improves the application. Secondly, in terms of the consistency of operation, there's a process in Java called garbage collection. And the process in general is responsible for allocating and freeing up memory as an application is run. And one of the reasons that Java as a platform is a very secure language relative to other things like, say, C and C++ and other language, more legacy type languages, is because of the fact that the memory is managed by the Java virtual machine. It's not the responsibility of the application. Many of the kind of famous security vulnerabilities that you've heard of relate to poor memory management by the application, holes in algorithms in terms of allowing attackers to come in and attack the memory of the application. So all of that actually is much more robust in Java, but it does come at the expense of this process called garbage collection. And garbage collection basically is a process that happens during an application as it's run to basically free up memory. In a regular Java virtual machine, the freeing up and the coalescing of memory actually requires the application to stop. So you get these pauses while the application is being run. So it's a very important process and a necessary one, but also one that can impact performance. A high-performance Java platform like Azul's Platform Prime inherently fixes that. And so it has very, very consistent operation and eliminates those long pauses associated with the garbage collection process. And then finally, when a Java application is run, I mentioned before that one of the challenges the Java application has is that it does take some time for the application to actually start up and eventually get to the fully optimized state. And this is sort of the downside of the fact that there is a compilation process that happens when an application is started, right? So like I mentioned, the JVM is responsible for compiling that application into the underlying instruction set. The downside of that is it takes some time. Compilation is a complex process. The more time you spend, in order to be able to generate high performance code, it does take some time to do that. And so that's what's called the startup and the warm-up time associated with a Java application. And so Azul Platform Prime has specific technologies, we call it ReadyNow, that addresses and significantly reduces startup and warm-up time commonly associated with regular JVMs.
What type of enterprises look at a high performance Java platform? What kind of enterprise will actually benefit from it?
In a very broad manner, businesses that run mission critical applications based on Java that have large deployments oftentimes have a need for a high performance Java platform. And to give you some specific examples, a lot of our business, for example, is with very large retailers and e-tailers. So they have lots and lots of transactions going on at a given point in time. They have lots of infrastructure required to run those applications. Many of those applications are written in Java. And as a result of that, they have a lot of spend that they're doing with both their on-premise data centers as well as their cloud deployments. And so the cost of deploying this complex set of applications to do a full end-to-end transaction in retail or e-tail, that's a very costly type of thing that the IT organization needs to keep up to date and maintain. A high-performance Java platform, in that particular case, by running the applications faster, it means you need less infrastructure to run. That can save on your on-prem costs. It can save in your cloud costs. And so Azul Platform Prime, for example, is very popular with large e-tailers and retailers. Other examples, you can think about markets that care about speed and performance and latency. So a classic example of that is trading. So big banks that have trading applications are trading equities, they're trading bonds, fixed incomes, they're trading foreign exchange, etc. Speed really matters in that market, and so that the first to process a trade, if you're an exchange, being able to rapidly accept a trade and close out that trade, those things absolutely drive success and failure in that market. And so speed is everything in that space. Azul with Platform Prime, we actually have 10 out of the 10 largest trading banks actually all use Azul Platform Prime in their trading applications because of its performance and scale and low latency, et cetera, et cetera. So another example that's kind of similar to that kind of trading is ad tech. So ad tech, of course, is the infrastructure that places ads in front of your eyeballs, based on your behavior and based on what the websites that a user visits. Decisions get made in terms of what you like to see, and advertisers obviously pay for those spots to put their brands in front of your eyes. And so again, it's a very high transaction type of application, and one which requires very quick decision making to be able to keep up with the ever changing opinions and preferences of consumers. So that's another classic example. Other examples, for example, SaaS companies that inherently have very large amounts of cloud spend. SaaS in general is very commonly associated with deployment in the cloud and lots of cloud spend. And if you think about a SaaS company, the gross margin associated with running that application in SaaS companies, for example, Salesforce is probably the most famous SaaS company, or Workday, or Canva, or these very large firms now. They're all using very large deployments in the cloud. Anything that they can do to save money in terms of serving the service that they provide is truly bottom line dollar savings. And so SaaS companies oftentimes use high performance Java platforms like Azul Platform Prime to, again, contain their costs, being able to have higher transaction while a more optimized cost infrastructure, et cetera. Other examples, gaming companies, again, very high, large volumes of users, being able to have very tight latency requirements, as many of these games are real-time games and users need to respond to one another. And so being able to do that with very high performance and inherently lower cost, very important for gaming companies. So list goes on, but that gives you a feel for the types of workloads and businesses that look for a high performance Java platform.
You folks also have a Java Performance Engineering Lab. Talk a bit about what is that lab and how does it enable developers and, of course, customers to optimize their Java performance?
We're in the business of helping our customers achieve the greatest performance and scale possible with their applications. And so we have what we call a performance lab. And what the performance lab is basically an area for Azul engineers and our customers, developers, to interact and share code, share ideas, being able to really analyze applications to deliver the best value for our end customers. And so LMAX is a great example of that. They're an exchange in London, and they've been an Azul customer for many years, and we've engaged with them with the Azul Performance Lab, and the results that they've achieved with the combination of continued improvements that we've made to Platform Prime, in addition to continued improvements they've made in their application based on what we have been able to advise them, based on what we can see, when running on Azul Platform Prime. We have some unique visibility capabilities that allow us to advise them, hey, if you did this a little bit different way, then the performance could be even greater. The combination of those two effects, over time, they've improved the performance and the latency of their main Exchange application by 48%. So the results are quite dramatic, and as you might expect, certainly in a market like that, that has significant benefit to their overall business.
Let's also talk about what is the role of benchmarking in this process of optimizing Java performance.
Benchmarking is an interesting thing, right? Because different applications behave in different ways, and so there's tons of benchmarks that are available for not only Java applications and Java infrastructure, but really pretty much every language out there, right? And so it's really important when you talk about benchmarking that a wide variety of different types of benchmarks and tests are performed when you're trying to say, how fast is Azul Platform Prime relative to just a regular JVM. And so we, as you might imagine, it's a performance product, and so we spend a lot of time comparing Azul Platform Prime to other JVMs out there. And so benchmarking is really kind of in our DNA. And so it's part of what we do in the performance lab. It's part of what we do in our normal QA environment. But the key thing about benchmarks is, again, the breadth of things that are run. And so in our typical QA cycle for Azul Platform Prime, we have over, I think the number is now nearly 500 different tests that we're running. And we look across the entire gamut and measure ourselves against the off-the-shelf JVMs. And that's how we really think about when we say Azul Platform Prime is faster, has higher performance, has lower latency. We're not just talking about one single benchmark that we kind of cherry picked that Azul Platform Prime does so well in. We're talking about truly the aggregate across all these different applications. And so we recently announced that across that wide repertoire of applications and benchmarks, that in aggregate and on average, Platform Prime performs about 38% faster than an off-the-shelf JVM from wherever that may come from. And so whether that's Oracle, whether that's Amazon or their Corretto, Microsoft Eclipse, all those don't have any performance enhancements to them. And so the users of Platform Prime can expect about 38%, kind of plus or minus, depending upon the types of applications to be run. Sometimes much higher than that, sometimes not quite that high. But again, it's just indicative of a wide breadth of applications and sort of a general rule that users of Platform Prime can expect.
Organizations are becoming very, very cost sensitive. What kind of impact do these performance gains and improvements have on operational cost for enterprises using Azure's Platform Prime?
It might be a little bit counterintuitive to think, how is it that a high performance Java platform can reduce cost, right? Because you don't normally associate those two together, but the equation's actually quite simple. If you think about, say, a Java fleet that's being run in the cloud, and since most enterprises now are deploying in the cloud, and most enterprises now also are wrestling with cloud costs, right? And so it's a common problem now that we're hearing from really any enterprise of significance that's deploying in the cloud now is, of course they're getting great benefit in terms of flexibility and scalability and availability and resiliency, all those different types of things, huge benefits in the cloud. But, and it's a big but, Amazon, Google, Microsoft, they all make nearly 40% gross margins, in those businesses. And so as a result, enterprises are paying more to deploy in the cloud than they would, on an on-prem or a managed outsourced data center. So that's where, the relevance of companies in the space of working on more cost optimized infrastructure come into play. Their whole practice is now behind this. The practice is called FinOps, and there's a FinOps organization, FinOps.org, that talks about best breed practices. How do you go about monitoring, managing, maintaining, optimizing applications to be more cost effective in the cloud. So there's a whole ecosystem now that's focused on this. So back to the question, why does a high performance Java platform matter in this context? Well, if you have an application that's able to run faster, it means that inherently you don't need as much compute infrastructure in the cloud. So an application that has some sort of reasonable scale might require 100 compute resources running on AWS to be able to handle the throughput and the volume based on the business needs of that application. With no change to the application, simply by swapping out the Corretto JVM or the Oracle JVM, simply by changing that and instead using Azul Platform Prime, that 100 instances might drop to 80, 75, sometimes even less than that. So you get an immediate cost benefit because, of course, you're no longer using as many compute resources in the cloud. And so a high-performance Java platform runs Java code faster, which means you need less compute infrastructure, which ultimately saves money. And so that's really how you connect, why is it that a high-performance Java platform can actually reduce or optimize cloud spend?
And I was going through some of the latest news coming out of Azure, and we noticed that, through Azure's Platform Prime, customers can achieve, up to 37% performance improvement over other OpenJDK distribution. Talk a bit about what magic, what were you folks have done to make it achieve that kind of improvement?
37%, as I mentioned, is really an average. Sometimes applications and infrastructure runs faster than that. Sometimes not quite so much, but that's kind of a general rule of thumb that we work with our customers, and they oftentimes see. How does that work? So, some of the kind of the magic, if you will, the secret sauce that's in Azul Platform Prime, there's three plus kind of main features. The first is we have the world's best just-in-time compiler. We call it Falcon, and in essence, it creates code that runs on the underlying machine where it's being run. Again, could be an x86 from Intel or ARM or Intel or AMD. Could be an ARM64 processor. For example, like the Graviton processors that you can run on Amazon. Ultimately, a better compiler creates more optimized code, which creates faster execution speed for the application. And so, inside Platform Prime is the world's best just-in-time compiler. That's kind of number one. The second thing, as I mentioned, this problem associated with cleaning up memory and coalescing memory and that whole garbage collection process. Well, we've got the world's best garbage collector in the Azul Platform Prime product. It's called C4. And ultimately, it allows for applications to run, quote, nonstop, meaning instead of the common hiccups and pauses that are associated with the garbage collection process, the operation is smooth. Even if you're running in massive heaps, terabyte, 3, 4, 5 terabyte heap sizes, you can do that with sub-millisecond kind of worst case little glitches associated with the garbage collection process. So it really is incredibly scalable, very deterministic. And then finally, I mentioned this problem associated with startup and warm-up with Java applications. Azul Platform Prime includes a technology that we call ReadyNow that basically allows for the startup and warm-up information, the profile, if you will, when a Java application is run. That is saved when a Java application is run, and that information can be reused when the application is run again to dramatically improve the startup and warm-up time characteristics associated with the application. So it's those three main elements: the Falcon just-in-time compiler, the C4 garbage collector, and the ReadyNow technology ultimately are the main points of differentiation of Azul Platform Prime relative to regular JVMs.
Scott, once again, thank you so much for joining me today, and of course talk about the high performance Java Platform Prime. Great insights there. Thank you, and I look forward to the next discussion. Thank you.
Thank you, Swap. Always enjoy our discussions, and thanks again for the opportunity.